So, welcome everyone. My name is Rachel Morello-Frasch. I'm a professor at UC Berkeley and a collaborator at UC Berkeley Superfund Research Center. And it's my pleasure to host the kickoff of our PFAS community of practice talk series. And sorry, I'm just going to chat the link to the schedule of our community of practice talk series. So this came out of a meeting that we sponsored back in June in Berkeley to talk about issues of PFAS specific to California. And after follow-up with people, people expressed a desire to kind of continue connecting, have a listserv, and to continue sharing scientific information. So we've developed this talk series to achieve that goal and make it short and sweet and low stakes, about half an hour at lunchtime. And our speakers usually give about 7-minute, Pecha style talks and some time for questions. So today, it's my pleasure to present our first set of speakers in our community of practice series, Kathleen Attfield and Toki Fillman, both from Biomonitoring California, who will be talking to us about what the biomonitoring program is doing related to PFAS and some of the more recent studies they've been doing. So I'm going to pass the baton. I think Kathleen's kicking it off.
Yep.
Okay, great.
That's me. Okay.
Take it away.
All right. Well, thank you to okay, my audio is still on. Okay. Thank you for inviting us to be part of the kickoff for this community of practice series. Again, my name's Kathleen Attfield, and I'm going to talk you through sort of an introduction to Biomonitoring California, if you're not familiar with us, and some of the studies in which we measure PFAS. And then I'll pass off to Toki Fillman, who will dive deeper into an analysis using drinking water samples. Oh, next slide, please. So there are likely many on this call that are unfamiliar to the Biomonitoring California program. So some background is that we were founded by legislation in 2006 as a tripartite program between CDPH and two arms of Cal EPA, the Office of Environmental Health Hazard Assessment and the Department of Toxic Substances Control. And this legislation mandated that we determine biological levels of environmental chemicals in Californians, that we look for trends in these levels over time across geographies and different demographic groups, and ultimately use this data to help to assess the effectiveness of public health efforts and regulatory programs to decrease exposures to these chemicals. Next slide, please. Our general approach to understanding pollutant biomarker trends has been to conduct surveillance activities and look for indications of concern where we may characterize specific populations using community-based approaches. And these might be in specific geographic areas, specific racial ethnic communities or occupational groups, and in sensitive subpopulations, such as in pregnant individuals. Next slide, please. From the beginning of the program, we have been measuring PFAS and have addressed many parts of California and different populations, as you can see here with our general population surveillance and the BEST study in the Central Valley, and then in the California Regional Exposure Study in Eastern and Southern California. We've also looked in specific groups such as firefighters, pregnant individuals, and in Asian Americans. Next slide, please. Our studies are revealing the presence and trends of PFAS in California. And as probably everyone on this call would expect, we do see near universal detections of PFAS in the regional sampling that we performed 2018 to 2020 in the CARE study. We did thankfully see lower levels of PFAS in Californians than our comparison with NHANES for national levels. And for trends in demographic groups, we've been seeing higher levels in Asians, males, older age groups, and higher income and education groups. Next slide. Our sampling of pregnant individuals in 2012 to 2015, 2016, again, showed near universal detections, but decreasing levels of most of the legacy PFASs. In this sampling, we did oversample an Asian category so that we could look at 3 subgroups, and we saw higher levels in our Vietnamese subgroup than in our Chinese and Filipino groups. And this was a good indicator that dividing out into subgroups can help you see something that would otherwise be masked by grouping them together. We noticed a possible emerging issue of higher levels of PFBA than seen elsewhere. And since I know the folks on this call are interested in chemicals beyond PFAS, just a quick note of seeing lower detection frequencies in PCBs and PBDs, but they're not gone yet, and a possible increase in levels in the banned organochlorine pesticide HCB. Next slide, please. Our work linking sources of exposure to pollutant biomarkers is supporting the different regulatory efforts at the state. I won't steal Toki's thunder, so I'll move on from that first bullet point about serum PFAS and drinking water associations to next slide. Work of another epidemiologist here examining our Asian Pacific Islander Community Exposures Project and their fish consumption, and seeing associations of up to 60% higher serum PFAS levels in those eating 3 or more fish meals per week, and then even greater levels up to 124% for those eating fish parts. Next slide, please. So the timing of this community of practice series is really opportune for us because we want to advertise that we have a lot of opportunities for collaboration with the program. We're in the early stages currently of planning a future surveillance project, which will measure PFAS and many other panels, we would hope. So we welcome those who would be interested in helping us think about the study design, whether we could add on complementary components beyond what the Biomonitoring California requirements are, and of course, get in early with establishing data sharing plans. Also want to say that it is possible to do various epi analyses with our data. Some of our projects, it's possible to link to health records, such as between maternal samples and birth outcomes that is being performed at Northeastern and Emory. And also to be able to do additional analyses with our leftover samples, perhaps an example of linking to early markers of effect. We also have a plethora of data that we're getting to, but there's still so much more that can be looked at as far as linking our biomarker data to information on sources of exposure. So lots of questionnaire data, diet, occupation, hobbies, home characteristics, and water source, and then linking the possibility to link to external environmental and geocoded data sets. So an example of the one that we're going to be starting up with Rachel Morello-Frosch's group there. Next slide, please. All right, I assume the slides are going to be circulated, so this is just so you can have a list of our studies all in one place, the different panels and date and population information. Next slide. And just want to remind people that all of our studies are described on our website, as well as information on the distribution of the different analyte panels. So detection frequency and different percentiles. So that's all available for you to peruse. Okay, and I think with that, yes, I'm passing off to Toki.
Hey, good afternoon, everyone. My name is Toki Fillman, and I'm a research scientist with Biomonitoring California. And today I will be sharing briefly and going into a little bit of a deeper dive into one of our biomonitoring projects that has come about from collaborations between our department and our colleagues over at the California Water Boards. So this project focuses on associations between PFASs in drinking water and serum among Southern California adults. So studies from areas with high-level PFAS contamination, particularly from industrial manufacturing, have shown significant contributions of drinking water to overall PFAS exposure. However, few studies have focused on the general population. So the objective of this study was to assess the association between PFAS detections in drinking water and PFAS concentration in serum among a general population of adults in California. So this is a study that came out of the California Regional Exposure, or the CARE study that Kathleen briefly introduced. The CARE study was conducted from 2018 to 2020 in southern and eastern regions of California. The CARE study was carried out regionally and used a quota sampling approach where the quotas applied were based on gender, race, ethnicity, and subgeographic area in order to best represent specific regions of California. So the CARE study measured 12 PFASs in serum in addition to other contaminants, and also asked participants to respond to an exposure questionnaire covering the topics that you see listed on this slide here. For levels of PFASs in drinking water data, we use data from the California Water Board's PFAS monitoring program. So between 2019 and 2022, the California Water Board carried out 3 phases of PFAS monitoring with investigative orders sent to water systems. So on the right side of this slide here, you can see a simplified diagram of a water supply distribution system where we have water from 3 wells flowing to a treatment plant before being distributed to households. So the 2019 to 2022 investigative orders from the Water Board sampled primarily from source wells as opposed to finished water or delivered water to households, and also had a small amount of water sampled from treated water as well, and focused on areas with either known or suspected PFAS contamination, such as wells near airports, landfills, or military facilities. And the drinking water monitoring included 18 PFASs with the statewide required reporting limits in the 2 to 4 nanogram per liter range. So we then matched CARE participants to public water systems and drinking water data. And to do this, we first geocoded our participant home addresses and then matched them to a water system service area boundary, as you can see an example of here, and then linked to drinking water data. And of course, we only included drinking water data from water systems in those 2019 to 2022 PFAS monitoring orders. We also excluded participants who reported that they get their water from a private well. So our final data set included 563 participants. Due to the brief nature of this presentation, I'm not going to go into this full slide here, but we can come back to it if we need to. Among the 563 CARE participants matched to drinking water data, we found that 47% of them live within a water system service area with at least 1 PFAS detection among the 11 analytes that were in both the CARE studies and drinking water data. So in this map here, you can see the geographic distribution of CARE participants matched to water systems, and participants whose water had at least 1 detection out of the 11 analytes are shown as orange dots, and participants whose water had no detections are shown as yellow dots. So also to look into the association between drinking water and serum, we did need to assign a drinking water exposure measure for our participants. And as a reminder, the Water Board's monitoring from these investigative orders focus primarily on source wells rather than finished water. So when we started out this project, we did have the ideal goal of being able to take the source well measurements and then estimating or calculating finished levels that's actually in finished water. However, of course, actual water supply distribution systems are much more complex. And so there are many challenges that make estimating PFAS levels in finished water difficult, particularly at the California-wide level. So therefore, after working with our water board colleagues and looking into the available data, we concluded that we could not accurately estimate PFAS levels in finished water. So given those challenges and the data available, we decided to assign crude categories based off of PFAS detections using the statewide reporting limits. So we categorize water systems into a binary category: water systems with no PFAS detections and water systems with at least one PFAS detection. And we did this for the analytes you see listed on the right side of this slide here: PFHXS, PFOA, PFAS, as well as a sum of 5 PFASs number, which includes the 3 analytes you see here: PFHXS, PFOA, PFAS, but also PFNA and PFDA. And in the second part of our analysis that I'll share today, we use the same drinking water binary categorization, but also looked at the subgroup of participants who are matched to water systems with post-treatment drinking water data. So in other words, representing drinking water that is likely to have been combined, blended, or possibly treated for PFAS. Okay, getting into our final results, looking into associations between PFAS detections in drinking water and serum concentrations. So when we first include all 563 participants and drinking water sampled from both source wells and post-treatment water, we found that people living in water systems with at least one PFHXS detection had 32% higher serum levels compared to people whose water had no detections. As you can see here, we did not see significant differences between people's serum levels for PFOA, PFAS, or the sum of 5 PFASs. In the second part of this analysis, when we limit the drinking water sampling to post-treatment drinking water samples, we found that 235 out of the original 563 participants were matched to water systems with treated water. And we found that participants living in water systems with detections had higher serum levels for all of the PFAS analyte models compared to people whose water had no detections. As you can see here, 81% difference for PFHXS, around 30% for PFOA and PFAS, and then 40% for sum of 5 PFAS. So in conclusion, in this general population of adults in Southern California, we found that PFAS contamination in drinking water may be a significant contributor to serum levels, even among a community without high level contamination from industrial manufacturing. And finally, I'd like to acknowledge that this is work that came about from strong collaborations with colleagues from the California Water Boards, from the Department of Toxic Substances Control, and other important members as well. And we're currently working on a manuscript and hoping to submit it within the next month or so. And thank you very much. With that, Kathleen and I will take any questions.
Yeah, thank you, Kathleen and Toki. That was super interesting. We'll open it up now for questions and comments. You can either just go ahead and raise your hand or put something in the chat, whatever is easiest for you. And if you want to stop sharing, then I can see hands. Probably could see more faces, but. Questions? I had a question. I'll kick us off. Are there plans to kind of expand this study to some of your other cohorts or biomonitoring studies to see whether or not you see similar patterns?
We don't have active plans at the moment, but it definitely could be done for those that we think are at least analogous in time enough. Given the 2019 to 2022 data window.
Yeah, yeah.
I think UCMR5 would also be a great data source as well for some future studies.
Yeah, that's what I was thinking as well.
Cindy is asking how many study participants were on private wells, Toki. Cindy Hugh, sorry.
Okay, it was a pretty small number. I don't have the exact number off the top of my head, but I think it was around 8 or 9 or so. So we only had to exclude a small number of participants.
Yeah, thank you, Toki. I was wondering if you've seen the recent USGS paper. They have a machine learning predictive model for estimating PFAS detection in groundwater at the level that's appropriate for drinking water consumption for the contiguous United States. So I was wondering, if you have more studied participants, it may be a worthwhile effort to leverage results from that paper to estimate drinking water levels for them, even though they're not in your drinking water measurements.
Thank you for sharing that paper. So that would be specifically for private wells, or because we don't have.
No, it's for groundwater wells,
mhm.
and then they do have results for different depths. So if you know the depth of the wells, it will be more accurate. And if you don't, then there are other ways of estimating that. I can share the paper as well.
That would be great. Thank you so much. We don't have that kind of granular information about the specific wells from this study, but I would definitely be interested in taking a look at the paper.
I'm chatting what I think is what you were just referring to, but you can correct me if I'm wrong. Folks who are interested.
Okay, that is specific to PFAS. Okay.
Yeah, based on the date, it should be right. I was gonna just find the paper. So. Oh, and there's a link. Yes, that's the
Yeah,
one.
they have a link to the study.
Thank you.
Other questions, feel free to just chat or shout out.
Hi, this is Ian Oots with DTSC. Thanks for the great presentation. I wondered, and maybe this is more obvious to others, if you had any guesses, any hypotheses as to the sources of the PFAS that are being found. Because when we say water system, and then you're looking at pre and post treatment, are you talking about the difference between groundwater plumes, or sources in the physical infrastructure, or things like that?
Thank you for this question. We haven't specifically linked our data with specific sources, but just speaking to California, we don't have industrial manufacturing, so the potential sources that could be contributing to the groundwater contamination here include industries that use firefighting foam, such as airports, military facilities, or it could be due to consumer products that end up in our landfills. But we haven't, as I said, linked specifically to look at the actual data of which point
Well, I could
sources
show
are.
you the graph from your paper. The water boards have also done a lot of sampling of wells near potential sources that she was talking about. So that's definitely impacting the water source supply in California.
So it sounds like you're saying it's a source, it's like a source that's impacting the groundwater that then is being consumed, and then you're seeing trends, initial trends with areas with and without known groundwater impacts, it sounds like. Is that so? Areas that maybe use groundwater for drinking water are more vulnerable would be kind of something that I'm reading between the lines on.
I believe so. I think groundwater is more likely to have PFAS detections compared to surface water. But
That's hard to say. It really depends regionally. Especially those that rely on a lot of recharge into the surface waters, such as down in Orange County. Yeah. Yeah.
I can also just jump on right here and say that this is something that our group has looked at to some extent. We've mapped all of the sources of PFAS that are sort of the recognized sources, which are also the same sources that were used in that USGS paper that was just shared. And then we've also been looking at additional data sets of newer, less well-known or less well-recognized possible sources of PFAS, like pesticides that may contain PFAS, the application of biosolids and CAFOs. So it's a great question. What are the sources? And this is something we're looking at as well.
And I see that Wendy's on the call. Wendy Link, can I call you out for information about PFAS being introduced within the system and the
Yeah,
current
I just-
responsibility?
Yeah, I think it's something that we're trying to have it associated as well. I mean, Toki mentioned that the sampling efforts and the data that was collected was between that period of 2019 and 2022. And they were biased. They were wells that were near an airport or a landfill. And so that's just to keep in mind in regards to that, because we wanted to know what the presence or absence of PFAS was in those areas. I think we'll get a lot better idea of the extent of PFAS in the state when we complete our current study within the water boards, when we're sampling nearly 4,000 wells, all public water supply wells within disadvantaged communities. And that data is actually being populated as we speak. And so, you know, there's obvious associations that will most likely that are associated with those drinking water wells. Those wells are quite deep. And so it is difficult question to answer. I agree, especially in Southern California where the water gets recycled quite a bit. And so it just kind of becomes a big giant pool of impact and whether it can be associated to a specific site or not. The other limiting factor in regards to association that you could maybe do a little bit more association is that data that was used is 18 analytes that's using EPA method 537.1. And it includes all the older legacy compounds. Currently, water supply or public water systems are using EPA method 533 now, which expands to 25, which includes some of the newer chemistries, some of the precursors. And that can kind of give you some association as well, especially regards to the use of aqueous film forming foam. And there could be more of a fingerprint that could be associated with a little bit more of an expanded list of PFAS compounds. And so that new data set that's being collected as we speak for the next year or two with those 4,000 wells includes that larger set, and all public water systems have to now sample for EPA method 533 going forward since after the end of Toki's data set. Anyway, so that's where we are. And I think we'll have a much better picture of the extent of PFAS statewide in the next year or two.
Thanks, Wendy. And thanks, Kathleen and Toki, for your great talks. We had one last comment from Kimberly Hazard, who just wanted to remind us about leads on consumer product categories contributing to groundwater contamination. Our great interest to DTSC's Safer Consumer Products Program. So this concludes our first Community of Practice talk series. Our next one is on January 6th, and we'll feature John Jacobs from the Department of Public Health in Hawaii. Is going to be talking about PFAS in soils, compost, and biosolids, something that we touched on today. So hoping to see everyone back again. Thank you for your great questions. And I just chatted again the schedule so you can see the full lineup coming up once a month. So hopefully see everyone next year on January 6th.